It doesn't bring up anybody else's, but depending on the speed, it's basically downloading the server or loading, sorry, onto your individual plots. And I can go in and take a look at those, the ones that I've already generated. I can view a LandPKS report, which will basically take me to that plot, or I can create a new plot. And I'm going to go ahead and do that. I'm going to do that for someplace that hopefully has a decent soil survey. Let's go further east. Boulder is not known for its high quality soil surveys. I'm going to create a LandPKS plot. So you can create a LandPKS plot in advance if you don't have internet access. I'm going to call this one Lupton. And if you can also obviously create it using GPS on the fly at the location in the field. So either pre-planning before you go to the field. The advantage of doing it in advance is if you, for some reason, you do not have internet access at the time, you'll be able to download all the information that we preload for these plots. So the way the app is structured is we have two tabs, a report screen and an input screen. The report screen is basically where all the information is available to you, both the information that we have preloaded from the cloud and then information that you provided through data input. And in some cases, we simply summarize. In other cases, we process to generate additional indicators and information. Straight off the bat, we go to Soil ID, and it has downloaded all of the soil profiles from the home map unit, which is the triangles, and the adjacent map units. And it has ranked them in basically using an algorithm based on location. So it weights them based on the dominance of the map unit components, the soils in your map unit, and the relative dominance and distance in the adjacent units. My soil has not been populated because I haven't provided any information. The stipples show what the texture is by depth. I can switch that and look at things like rock fragment by depth. I can look at color by depth if I'm in the US. The international don't have it, and of course, some of the US profiles are not populated by color. Whoops. Yeah, this is what I get for going back and forth between phones and forgetting where I am and being on too many planes. I'm going to go ahead, 11 left and, oops, lower about. There we go. Okay. So I can go back then, and the other thing that we previously preloaded is climate information for your area. And anytime you have questions about where those climate data come from or anything else, you click on the question marks. And if, as you're running through the app in the future, if you run across something where you wish we had a question mark, please let us know and we'll add it. We're trying to provide textualized information throughout. That's about it in terms of information that we currently preloaded. There will be more in the future. I can go to the data input side and start entering data. Again, everything is optional. It's like Farm OS. You can start anywhere you want. I'm going to go ahead and start with slope. We can use pictures. We also have a slope meter that just, and we try to take advantage of as many of the tools on the phone as possible. So I can go ahead and use that clinometer. There's a slope shape. I'm not going to go through the entire app today, just give you kind of an idea. Texture is the big one. This is obviously in centimeters. I'm going to go ahead to the application settings, switch to English units, since that's what a lot of the farmers are going to be using. there in the application settings, I can also switch to Spanish, Kiswahili, or French. We'll stick with English today. And then I start entering textures. And basically, the reason we're asking people to enter texture is because it provides a lot of information by itself, but it also helps us then to use another algorithm to identify the soil. I can enter directly, or I can go through a guide me process. And basically, we're just leading people through a key. And if they're not sure what that text in the key means, we have embedded videos. Again, all of this is operating offline. The only thing that requires online is the soil identification of the climate. We go down through and it identifies this. We're continuing to do a lot of research on how we can improve these texture estimates because they are so important. I select my rock volume and I go down to the next step. And just for demonstration purposes, I'm going to pick a few here. And okay. And at this point then, we can document soil limitations. We can determine soil color using either any color reference. In this case, I'm going to use a 3M post-it note for my color reference. And it's already selected in the settings. And to determine soil color, I simply take a photograph of that 3M yellow post-it note, or ideally a stack of about 3 of them. And in a room with more uniform lighting than I'm sitting in today, we'll go ahead and do it anyway. I touch the card, telling it what the reference is. I touch the soil, and it's saved, and it gives me my color in Munsell. We can also provide it in LAB or RGB for those that are interested. You can do that for all the different depths, and then hit synchronize. And basically, it's sending the data for storage in the cloud, so I can then access it on any phone that I log in with my Gmail account. It's also running an algorithm in Soil ID. And again, I've got the rankings based on the GPS. It's also re-ranking it based on my data on based on the data alone, and then based on an algorithm that combines the GPS plus the data. Okay, and so you can see that the ranking of those changes. So depending on how confident you are in your data inputs, you might want to use the data only as a match, or you may want to use one of these other ones. You can also go back to data input and add additional textures. Okay, the other thing is that there's it will calculate the available water capacity, the infiltration rate. You can play around, and I'm going to go to one that has more data into it. You can play around with organic matter content. So this is run on standard pedotransfer functions, and as we all know, the effect of organic matter on available water capacity and infiltration rate varies widely, depending on what type of organic matter we have. But this provides at least a pedotransfer function that in this particular profile, it's basically a clay, is showing that you get a dramatic increase in infiltration rate and relatively little increase in AWC. Again, it depends on the soil, and we're running a standard pedotransfer function that's available in the literature. On the data input side, then, we have a number of the other modules. So that was the land info module, which is the basic one, determining what the potential of your soil is. This is, you would do that once at a location, and then you basically got it stored permanently. We're anticipating that people are going to start to use this for things like septic design, because a lot of people, if they want to do a septic tank, the only thing that they really need is their texture. Gardeners, master gardeners have indicated an interest just in learning, basically learning about their soil. And I remember got a K-12 curriculum unit, 7th grade focused, under development that should be released in October, and several other groups working on environmental science education have indicated an interest in incorporating into the curriculum. And a lot of them are focused on that land info because it helps the kids just get an understanding of what their soil is. What is soil? Then we've got the land cover, the land management module. And again, this should look very familiar. I can define the area of my field in whatever units I decide. So let's switch here to acres. And we've got a 3-acre field that we're representing. It was first cultivated in 2004. That's important for initiating the models and predicting carbon content. I then go to the field calendar. And basically in the field calendar, I can pick any date, present or future. This can be used as a planning tool, again, very similar to FarmOS. We'll just click on today. And we wish we'd gotten rain here in Colorado today. We haven't. But I'm going to go ahead and be wishful and put in 1 inch. And then maybe another inch later in the day. And then can record basically anything that I want. And again, this is where these screens are the ones that will be looking to work with other partners in Open Team to standardize these things. We tried to make it as consistent as possible with NRCS and consulting with Keith's group, with what they use, but at the same time keep it reasonably simple. And as you can see, we're catering both to the US and to overseas that might be using animal traction. And so forth. And so we can basically move down through that. There are erosion control practices and so forth. And it shows up on the calendar. We can use the calendar itself as a reference tool, but we can also go back into the report, and all of that will show up in the report. We can create an output for the month, say generate, and it generates summary information. We can get a complete history of what we've done. We can download a PDF report and send it, et cetera. So we're trying to provide basically as much functionality as we believe people are going to need on the phone itself. Yeah. Okay, great. Switch. So can we just go ahead and read it? Because we can.
Yeah. Can you give a little more on how we represent soil capability? So you might want to demo the LCC.
Sure. Yeah. So LCC, and let's see if I've got one. I think this one is probably populated already. So on the data input side, we need a little bit more information. Soil texture is a big part of it, as is soil depth, but there are additional soil limitations that we need to address, like vertical cracks in the soil. And again, clicking on the question mark gives you a little picture, describes what it is, and then you select one of these, and we'll say no cracking. Salt on the surface, indicator of salinity issues, flooding, lime requirements, and so forth. This is all calculated on the phone. If I go back to the report, and the land capability classification is a system that was developed by USDA starting in the 30s, following the Dust Bowl. And what it does is it ranks locations on a scale from 1 to 8 classes, 1 to 4 being arable with increasing numbers of limitations, and 5 to 8 generally being non-arable lands. It has a number of subclasses that corresponds to those limitations. And what we've done is we have automatically generated that classification using an international system that we developed. So we basically looked at all the different ways in the United States, as well as a number of countries around the world. But then we also allow users to adjust it, recognizing that some limitations may be removed or may not be relevant. So in this case, we have a 4WD, which is a problem with water table depth. But if what I'm going to be doing is growing flooded rice, I don't care about that. I don't care about permeability. And there may be some surface texture limitations in terms of planting. I'll go ahead and leave those in there. So I now have a 3ST. Okay? And so that's basically saying that I've got some limitations, but they're not as significant as what they might appear. I'm going to tap on the US LCC notice. The great thing about the US is every soil, or just about every soil, not some of the minor ones, have been classified for their state. And the nice thing about that is they integrate climate as well. We didn't integrate climate as a limitation because climate limitations vary widely depending on the types of crops, the genotypes, and so forth. So this is a soil-only limitation. And when you download it, in fact, if we go to the soil ID, and I'm going to go back to the US plot now. I go to our soil ID, and I click on one of those, it actually will link to the soil information, and we're automatically downloading the land capability class, which in this case is 6E. It also allows us to link out, both these are URLs, web links, to the data that NRCS provides about that soil. You can view the lab data, basically getting direct access to all that information. We can also link, if you're in the West, to the ecological site data. And this is a site where it basically provides a lot of management information about those soils from a rangeland perspective. And it's linking again to another website. So you're now outside the app. Okay. Other questions?
There's another question on, is there a way of marking assessments as complete?
Okay. There is not, and that if you guys have got suggestions on how to do that, our biggest challenge right now, after we get over the privacy issue, is in fact navigation. A user in Ethiopia described LandPKS as a dinner roll, a round one. You don't quite know where to begin to bite the roll, but once you start chewing, you start to understand it. And so the entry point is something that we're working on, and then also that completion, and completion is going to be something different for everybody.
So we've actually gone back and forth on the completion. At one stage it was a linear, you enter all data and you couldn't re-edit it. And then we changed to any data can be updated at any time. The timestamp data is separate. So land management, land cover is timestamped. There are a couple of other questions on, is LCC global? The answer is yes.
Yes.
But we also do pull the Surgo LCC within each soil ID.
Which is what I just showed.
Did you just look in that?
Yeah.
There was a question about, is the data available to pull over an API? And the answer is yes. There is a publicly available API for pulling data. And we're currently implementing an API to push data into the system as long as you're an authenticated user with an API key. That was it. You're up to date on questions.
Okay, great. Megan, anything else that you should highlight?
Just on the marking completeness. So for example, for soil ID, as you enter in more relevant data, there's a little bar at the top that progresses. So for certain sections, there is an area to know how much data you entered, but not for kind of the overall point or site entry.
And that has, as Karen indicated, that's been a real tension. We started off very linear, almost ODK-like, in the way we were approaching it, and we got an awful lot of pushback on that because basically every user was using it differently. So we've now switched to this. We've swung the pendulum now where you can start anywhere and end anywhere, and clearly we need to provide a little bit more structure to it, and so we'll work on that. But basically starting with the questions people have. So our ideal is that in the future, instead of on the report side, seeing a list of names, you'd see a list of questions. And you basically start with a question, and then the app would lead you through what you need to do to better answer that question while providing an initial answer based on data already available in cloud. Anything else, Megan? Yeah.
No.
There are a number of other features. So if you go to more, if you don't want to do a whole plot, you just want to determine a color or texture using the guides, you can click on one of these tools and just run through this. People are starting to use it as just sort of a toolkit kind of a thing. The same with climate. You can click on the climate button down at the bottom and do the same thing. I'm going to switch now back out and go to the module that's not yet complete, which is SILA Health. And I know this is one that's of quite a bit of interest to a number of folks on the call. Again, we're starting simple, starting with just field observable indicators. This is just one of the example. This is currently being coded. Again, should be available certainly by November. We've again drawn on existing systems wherever possible and categories and so forth. Other features coming by early 2020, Polygon Creation on the website. This is currently entirely point-based. We will allow you to create a polygon on the website and then link that point to the polygon. And again, I think this is where some of the integration with FarmOS is going to come into play. And one of the reasons we actually haven't started on that yet is we want to make sure that whatever we do will be portable. Optional data privacy functions, hoping to finish that actually well before the end of the year if we can. It'll be a fairly simple system. We won't be assigning roles initially. It'll just be on and off. Additional vegetation monitoring features, forage biomass, forage utilization, the Nature Conservancy, and also habitat interpretations. Nature Conservancy got some funds to work on that, so we're working with them. I'm going to switch now to the website. We will be, we're going to be reworking the website pretty extensively. Megan's been working on that recently. We do have a data portal, which is pretty simple and not coming, there we go, coming up. And basically, currently you can just, it's more of kind of an exploration tool. You can click on a point anywhere in the world, you can zoom in, you can see a summary of the data. You can download your own data from my own Gmail address, where I can hit all, download all of the data. I can do it for land info, land cover. Again, the data portal is something we actually haven't worked on in probably 3 years, and it's showing its age limitations. We actually started off with a graduate student programmer model, and we still do use graduate students, but obviously with Karen coming on, it's been basically professionalizing the entire operation, and we haven't hit the data portal yet. So that will be coming. Something else I wanted to highlight is one of the things that we're doing is we are working as hard as we can to make sure that the data that the user generates are as compatible as possible with other existing data sources. And this is just one example. This is called the Rangeland Analysis Platform. This was created by a team led by Brady Allred up in Montana. And basically what this is doing is it's using remote sensing analysis going back a number of years to predict perennial cover, and this is rangelands, and a number of other indicators. And it's doing this using a training data set that was generated by BLM and NRCS. And that training data set used a set of standard methods that we actually developed at the Ornata about 15, 20 years ago. There are well over 40,000 plots available in that data set now that have all these indicators in them. And they were measured on the ground using robust methods with QA, QC, and so forth. And so it's a pretty good data set. What that means now is that if I'm a rancher and I zoom into this and I find that it's predicting that I've got about 40% cover in this particular field, I can go out and I can measure that myself with LandPKS using the land cover module, which I didn't demonstrate, but basically just uses a yardstick and 5 points on it, and takes about 20 minutes or less. And I can get my own value and I can compare it with that. And that's one of the reasons why the ranching community in the United States is so interested in the app and is waiting for the privacy functions to be implemented to really get on board. We've got strong support from both the Matt GLC as well as Public Lands Council, and I'll be up in Montana again at the end of the month, visiting with the Public Lands Council and make sure that we're on track working with them. But we've been working pretty closely with them. So again, the whole idea that one of the team's key concepts of common data standards wherever possible, we found is just incredibly powerful because it opens up these massive massive data sets.
We have a few more questions about the API.
Great.
Is there documentation? Our documentation's like out of date, but you can get to older documentation and an Explorer on our website, which Jeff has up at the moment. We are updating the API over the next, it should be out in the next month. And there's a question about, is it easy and flexible to push data with the API? To create a plot in our system, all you really require is an authenticated email address, which we use a Google sign-in to get the tokens, and then you can get that from our portal to use to push data into our system. The only thing you need to create a plot is a name, a lat, and a long, and all other data is optional. So after that, you can just build on top of it. At the moment, we're the main consumers of our API. The app itself is the main consumer. We use our public APIs in the app ourselves and on our portal. So I don't believe, is there anyone externally using it? But so in terms of what types of systems could use them, it's really any system like ours could also use them. You talked about how LandPKS will or would it integrate with SILA Web or Web Soil Survey.
Yeah. So Web Soil Survey is NRCS's product. SILA Web is a product of the UC Davis in collaboration with NRCS. You can access both on the web. SILA Web finally was able to come out with an updated iOS version, and you can download that as an app. We actually hit their API, SILA Web's, because they've already pre-processed some of the soil data. They bring in a new set from Web Soil Survey, or Sergo actually from every 6 to 12 months, an updated set, process it, and then we collaborate with them. We have intentionally kept, excuse me, SILA Web and LandPKS complementary. SILA Web is really more designed for the user that wants to go in and I'll switch back over to the screen here again. For the user that wants to drill in to that, those details, right? And so you can see we're actually UC Davis is what we're hitting here, and you can look at the lab data. It's really designed for people who are already familiar with soil data. What we're trying to do is make soil information accessible to people that didn't know there was such a person as a soil scientist. And the home gardeners, the folks that buy a farmette or a ranchette, or a farmer that just doesn't want to get into all the terminology. However, SILA Web is really nice because it does provide an incredible depth and richness of data. And so we will probably start cross-promoting. In fact, we will start cross-promoting the two apps, so that people actually get to the app that does what they want it to do. And our guess is that a lot of folks are going to have both of them on their phones. And like I said, it's been a really nice collaboration with Dylan Bodette. So Dylan did his graduate work with Toby O'Heen at UC Davis, went back to full-time with NRCS, and is now associated with the Seoul Survey Center. And so, yeah, so basically we'll continue that collaboration.
There's another question about how we integrate with the soil health indicators.
Right. So are you referring to the soil health indicators, any specific set of soil health indicators, NRCS, Soil Health Institute, or generally?
This is Doran. I was thinking about the NRCS soil health indicators where there's a placeholder in sort of web soil survey for them.
Yeah, so our intention after the dust settles and after we get this first version out is to provide a way for people to basically store them in LandPKS. So, and again, if somebody's has a bigger farm, they're probably going to use something more like FarmOS if they've got lots and lots of different samples. But if they've just got, one or two or three or something, they may want to just hold that on their app on their phone. So they've got access to it and they can track it over time and so forth. So we will provide data fields for that in the future, but we haven't been in a huge rush to put that in just because, as you know as well as anyone, Doran, things have been a little bit dynamic. But we would certainly welcome ideas and suggestions from this group on what the best way is to do that. Again, we don't want to overwhelm the casual user who doesn't have the money to send or doesn't want to spend the money on lab analysis.
The next question is, I'm curious if you saw Open Land Maps presentation last week. They create some nice global models based on training points. If you saw it, did you have any opportunities in working with them to create new global maps based on LandPKS data?
Yes, so we have, I've known Tom for probably 10 years. We first met each other and realized that we had very similar and complementary philosophies and approaches back when he was working at ISRIC. There are a number of opportunities, both with OpenSoilMap and also with ISRIC's product, which Tom initially created, which is called SoilGrids, which is a digital soil map of the world. And these are basically complementary soil maps that are complementary to the traditional soil maps that we're used to in the United States. And basically what they're doing is, instead of mapping soils, they're predicting properties. And they use unique, and I think Tom got into a little bit of this, but basically, for those who are on the call, these unique random forest models to predict properties at every pixel in the world. And ISRIC has one, Tom's got another that he's kind of regenerated, and soil maps, there are a number of other layers available through that, and he's doing the predictive modeling with vegetation. What I just showed you with Rangeland Analysis Platform is yet another implementation of that tool, or that approach. LandPKS will interact with these in the future in two different ways. One is we will increasingly provide users with direct access to those data through LandPKS. And again, we're trying to make sure that we do this in a way that doesn't overload either the user or the app itself. And number two, both Tom and ISRIC have indicated, and others as well, that they are likely to start using LandPKS data as additional training data. The biggest limitation of these is, as Tom indicated, when he was showing you the profiles that he was modeling based off of, and a lot of the countries where we have a high density of points are countries where he has very few points. The soil data that users are providing through LandPKS are obviously, well, not always, but often of lower quality than what might be provided, might be available from these standardized soil profiles. But they're clearly a lot more of them, or will be a lot more of them in the future. And in a lot of cases, people are actually getting a fair bit of training before they go to the field and do their self-characterization. So, it'll be interesting to see in the future the extent to which LandPKS data through our API are able to improve some of those other products. And then as we also then draw on them, where useful to our users. And again, always welcome thoughts and suggestions on that. How we should move forward.
Great. The next question is, what software license does LandPKS use, and is the code already available, or is that in process?
I think we would say that's in process at the moment. The intention is that all code we develop is open source, but we had some issues with pretty sloppy development processes where there were a lot of passwords directly in code, which would allow you to essentially log into our systems and get to our databases directly. So with our redesign of the APIs, we're cleaning up all of that, and we're tokenizing the APIs so that the code can be distributed in a safer manner, let's put it that way. So everything will be open source. The app itself is, actually the app code is currently available publicly. Anyone could go pull it down, but deploying it through any store would become an issue because it's tied to accounts. You would have to make significant changes to reuse it in a store. But the APIs, you could certainly stand up on any server and use them yourself.
This was a good example, and being completely transparent, of a soil scientist whose most recent coding was in 1989 in a class in graduate school, leading a software development project and not being quite sure who he was hiring initially. So Sharon is now helping us clean up those issues.
It should be said with that actually that the data is currently publicly available.
Yeah.
And the use of the API is publicly available. So all functionality is public.
Those are all the questions that are in the chat. Is there anything else?
We have a little more. Go ahead.
Oh, I was just going to ask, yeah, I imagine as we get into Denver, there'll be some questions around, for Kieran, around development environment and languages and repositories and all that kind of stuff. So maybe you might want to talk a little bit about your process and team process.
So our entire backend is hosted on Google Cloud. The data is stored in a MySQL database on Google Cloud. The apps themselves are hybrid apps. So they're a platform called Ionic, and the app itself is built entirely in JavaScript. The backend is all Python. Yeah, all Python. The APIs are REST API.
Other questions?
Hi, this is Sig. Can I just
sorry.
make a comment?
Yeah.
Okay, great. So I have some good news. You know, Alison Nord used LandPKS in Tanzania to sort of interface with extension educators and with farmers. And we got some positive reviews, or mostly positive. I thought they were positive. The student, of course, didn't quite see them with that perspective. But anyways, very much revise and resubmit from land degradation and development. And yeah, basically, she seems to have shown that, you know, getting people to really look at what farmers are doing in terms of documenting their land conservation type practices, and then finding they're not necessarily related to slope, but in her case, often related to water infiltration. I think that's really revolutionary. So kudos to you, and just keep working on the, please, you've done a great job on the soil ID. I really love how transparent that is on the water infiltration and interaction with soil carbon. As we get better measures of local soil carbon, we can really fine tune that because you made that flexible. So again, brilliant. Just hope that continue to you know, I look forward to seeing how this soil health module rolls out, and opportunities to comment on as it rolls out, so that, you know, it can be a really useful tool in addition, I think will be really interesting. But just as an opportunity to get people to dig holes and to interact about what their soils look like, so that extension and researchers really pay more attention to what farmers are actually coping with and how they're doing it. You know, this has really moved us light years ahead. So thank you, Jeff, from the bottom of my heart.
So I have to thank C, who's been a huge supporter for years, and also one of our biggest critics, which has been even more helpful. So again, as the idea of getting soil health out quickly in a very basic form is so that we don't screw up too much too early. So we want to, or we don't screw up too much before people have a comment or a chance. And what we're finding is that we've had more success actually putting simple stuff out that people then comment on and give us feedback on, and start to play with, and then we can develop from there. So yeah, soil health, everybody on this call, I'm looking forward to your thoughts.
And I do appreciate how you've done rounds of getting systematically assessments from people. That's a really, you know, much better than a lot of apps that just think that we should all be happy with them as is. So it's really a co-development project, which we really appreciate. And, you know, maybe you can continue in terms of how do people, when they're just using it, provide feedback. I mean, I know you're working on that, but it's an interesting bit to me how we make these co-development projects not just our friendship networks, but, you know, kind of with the community at large. So interesting stuff, and keep it going.
Yeah, thanks. And that's, I think that's a really good point. And actually, there's 2 points indirectly. One is sort of how you provide feedback on the information that's being provided, and we do have some ideas and working with NRCS, particularly on the soil ID piece of it, to provide feedback there. The other is then how you, and this is something Steve pushed us on for years and we still haven't gotten to, but and I think maybe with Open Team, this may be how it happens, but how you connect people. And so I think some big opportunities there. You said, Megan, you said there's another.
Yeah, there's one more question. Do you have API documentation?
Oh, yeah, Jeff showed it.
Yeah.
It is very out of date, but there is API documentation on our website. And we have removed all create and post methods because they were not authenticated, and we decided that wasn't something we wanted to do. So they will be replaced in the next month, or updated in the next month.
It's great. Megan and I were just in New Delhi with Keith, and everything loads faster in New Delhi than it does in CU. Amazing. Great. Anything else, Megan, or I can switch to?
That's all that's in the chat.
Great. So we've got a couple more minutes left. I'll just do a quick land cover demo. So this one is kind of fun. Whoops, let's go Dan first. So basically the way this works is you add a new transect or a new plot, and this would be centered obviously on ideally on some place you've already characterized, you know what the potential is. You can list the dominant species. We don't focus too much on species because most managers don't. They focus on functional groups. We walk out 5 yards, 5 paces, and we drop literally a yardstick or a stick off a tree with 5 points on it. And for those of you that have done point intercept methods, that's all this is. We're just recording what is covered by that at that individual point, and you can see the words coming up on the bottom, and the cover. And then you can use the same stick to measure height. You can use the same stick to record big gaps in the vegetation, which are important for erosion and also for wildlife habitat height and cover. And we can do species counts or densities. So if you're doing a seeding and you want to go out and do a quick check of density. You then go to the next one. We found that people take 1 minute or less to do each stick. A lot of people only do the cover, the point methods, and don't bother with the height and so forth. If we then go back to the land cover and the report, it automatically graphs everything. This is all offline. It will do trends over time for those plots that you've got complete data entry for, 100 points, and so forth. And that's the last of the four input modules. Anything else?
I had a question. It wasn't on your roadmap in terms of linking in with external measurement devices for adding more sophisticated protocols.
Yeah, so we've had a few preliminary conversations about that. It's certainly something that we can do. He was just asking about external measurement devices, but we've been focusing on getting the four core modules and the privacy out initially. But yeah, in terms of additional inputs, obviously the data fields are there. Can be done. It's just a matter of prioritizing.
Fantastic. Well, we're at the top of the hour here, so I thank you so much, Jeff and team for presenting. We're really looking forward to seeing you in Denver, and hope everybody here will join me in thanking you all, and look forward to seeing you at the next in-depth presentation.
All right. Thanks, Lauren.
Okay.
All right.
Well, welcome everybody. This is Dorn Cox with the Open Team In-Depth series, and super excited to have Jeff Herrick and the LandPKS team dive in. So I'll hand that off. If you can mute yourselves, but Jeff is happy if you want to jump in with questions along the way. Just unmute yourself and or put your text comments in the chat box. Thanks. There you go, Jeff.
Thanks. All right. My name is Jeff Herrick. I'm leading the LandPKS project, although leading is probably a little generous. I work together with a great team, two of whom are joining us here today, Megan and Karen. Megan is the global lead coordinator for LandPKS, and Karen is our lead software engineer on it. And we have several of the folks who are based here in Boulder, Colorado, folks in Las Cruces, New Mexico. We are global projects. I'm assuming everybody can see the screen.
Yes.
Okay.
Yes, it's working.
Sorry. Great. So we are. It is a global app. It's designed to be used anywhere in the world. We actually started off in Africa, and with a vision of providing global access to knowledge for sustainable land management. And our current mission statement is supporting farmers, ranchers, land use planners, and other natural resource managers, which often includes conservationists. A lot of TNC use, nation conservancy in Africa and the US, with open source tools that allow them to easily access knowledge and information and to collect, share, and interpret their own soil vegetation cover management data. We've been working on this for about 5 years, actually longer than that. The idea originated back in 2007. It took a while to convince somebody that this was a good idea. And led by USDA ARS at the Jornada in Las Cruces, New Mexico, but increasingly with very strong co-leadership by the University of Colorado. Jason Neff here runs the Sustainability Innovation Lab at CU. And of course, that then gives us opportunity to work directly with Colorado State University, Keith Palstrom's group up there, just up the road, and a really nice community here in the Front Range. New Mexico State University has been a solid supporter all along. The Jornada is based on the Annapolis campus, and of course, primary funding provided by USAID. It took us a long time to get going. As you can see, this is just the number of plot uploads. This isn't even users. We're now well above 10,000, I think 11 or 12,000 uploaded in an exponential growth phase, and that's even without having announced the new features. So we're excited about the fact that we finally seem to have hit something that has value in a number of areas. We'll talk about some of those as we go through. Looking forward, we will continue on sort of a contract grant sort of model, like a lot of the groups I know are using for the R&D side, and supporting implementation, particularly overseas, where implementation does seem to require some nudges, and we found that a lot of our partners are willing to go out there and basically provide those kinds of support. However, we are hoping to switch fairly quickly, move the app out of the federal government / university system into an NGO, or at least move it to a university sort of body that is a little bit more flexible in the way that they can support the continued development. This is where we started, the crime of the century, which was basically what led to the Dust Bowl. This doesn't happen to be in a part of the country where the Dust Bowl occurred, but similar issues of inappropriately, basically inappropriately land use, leading to soil degradation and reduced productivity. And that led to the development of the first module. So I'm going to slow down a little bit now and spend a little bit of time on this slide. We basically tried to create a package that can be used by virtually anyone who is interested in managing their land better, to first determine what the sustainable potential of their land is using the land info module, and then moving on to what's really FarmOS's strength, and we've drawn a lot of inspiration from what FarmOS has done, the land management and record keeping. On the biophysical side, we haven't actually gotten into economics. We may add at least the ability for people to add costs to their inputs in the future, but we don't see this as, at this point, moving into that sort of whole labor and financial management that FarmOS has become quite good with. So this is really kind of an entry point, more for a small landowner or a gardener or somebody that wants to get started, than somebody who's looking for a more comprehensive system. And then looking at the impact of your management with the land cover and soil health modules. Land cover focuses more on rangelands, where you're looking at a management response from the vegetation in terms of both cover composition and future biomass. And then it can also be used for things like weed cover and crop residue cover. And then on the cropland side, coming in November, or sometime by November, a soil health module that allows for field observations and future lab data record keeping, so just keeping track of monitoring change over time. And the growing number of outputs that are fed by these input modules, as well as online data that are available, and we often combine those through algorithms. And of course, this is where the real value added of engaging with the open team process comes. The things that are in black are things that have already been implemented and are available on the module as outputs, and the ones in gray are ones that are currently under development. Carbon sequestration, obviously collaboration there with Keith's group, and conservation practices with WOCAP, a global group that has a knowledge base that we're trying to figure out how to tap into and connect with, and so forth. And on the output side, there's really no limit to what we can do. We're trying to limit the input side because we feel that if we get too much more complicated, we're going to lose a lot of our users. And we're already struggling with that and working to further simplify the user interface. Again, these 4 input modules, each one by itself has multiple uses, and then frequently in combination. And again, I'm going to go fairly quickly through this, recognizing that this group will ask lots of questions at the end. And obviously, like the overall philosophy that Dorn has so beautifully expressed in the proposal and other fora, the idea is that, you know, with the big data that starts to come in, the big data analytics we can do, starting to generate precision management recommendations, or at least options. I'm going to switch now, but maybe stop for a second and see if there are any questions on the overall philosophy. Then I'm going to switch to a live demo. Is there anything coming on chat? No? Okay. All right, great. We'll go ahead and switch to the live demo then. So this is the app. We do require a Google linked login currently, basically as a way to link you to your information. We will be adding privacy functions later this year. Currently, all data are open, so anything you do on the app, as soon as you sync to the cloud, does become instantly available on the portal and available for download by anyone in the world. This is basically a list of plots or sites, and an awful lot of demonstrating what I'm going to do here today. There are a couple of different ways to enter data. One is by simply adding a plot, using the plus sign at the top. Another is